Assalamu alaikum everyone. Thanks for having me today. We are going to discuss about advanced rootkit detection via memory forensic. As you know, there are a dozen type of malware out of there: ransomware, crypto miner, infostealer, banker, wiper, and so on. And each of them have their own capabilities, mechanism, and stealthy. But none of them is like a rootkit. So I have decided to design this presentation for security researcher, incident response team, and SOC analyst, also malware reverse engineer, to know how to handle the rootkit case and how to remove from the system and recover into the clean state. A brief introduction about me. I'm Dr. Sadi Ali from Kurdistan, Iraq. I'm 24 years old, security researcher, spoken in many international conferences such as Black Hat, Ficon Party, Beside Budapest, Arab Cybersecurity Conference, DeepSec COSAC, and also the Volcom from India. Well, the main question is what's rootkit and why rootkit? Well, rootkit is a malicious software like any kind of the other malware, but that hides its presence to gain unauthorized access. Okay? Well, usually, many infected by a ransomware, you see a dark background says your computer has been infected. If you don't pay a ransom, we will sell your data on the dark web or in an underground market. If you're infected by InfoStealer, you may notice that your account passwords changed because InfoStealer is stealing your credential. If you're infected by the crypto miner, you may notice that your computer are slower than before. But for rootkit, you don't have any kind of the symptoms. Actually, rootkit use it to maintain undetected access for stealing data or installing the software. Well, each type of malwares may have loader and downloader or stager mechanism to stay undetectable on your machine or have multiple backdoors or for evade detection, and rootkit is one of them. And also, the rootkit is conscious malicious activity to avoid detection. Well, each process in a operating systems, you can easily see it and look on it by using tools like a task manager, process hacker, process explorer, and so on. But actually, for rootkit, there are no process presence in a user land. You have to use a specific toolkit to detect it and reveal the hidden process, and we will gonna discuss about it. And actually, rootkit require specialized tools and technique for detection and removal, and crucial for system integrity. Well, in the past, there are some tools that designed for detecting a specific type of rootkit, like a TDS killer by Kaspersky or Gmer, but they are designed for a specific type of rootkit, not all of them. And actually, the detection is a critical to maintain system activity, security, and protecting sensitive data. The rootkit life cycle. Well, each malwares have their own life cycle actually. For rootkit, first of all, infection and deployment, and actually privilege escalation to obtain kernel access and hide their own process or hide their own process. And this technique called DCOM, direct kernel object manipulation technique. And then privilege escalation again and command and control. So the malwares need to communicate with the C2 channel to stealing data to sending a command onto the infected machine. Well, the command and control actually is a sender and receiver channel between the attacker and infected machine actually in a simple term. And the final stage is malicious actions like altering or unlinking entire e-process to hiding their activity. So the rootkit can stay on your operating system on your infected machine in a user mode and in a kernel mode. Well, actually, we have a user mode and we have a kernel mode. So the user mode is a normal application and normal utilities and normal graphical stuff that you see on your operating systems, like applications. But kernel mode is a high level. You are working with the operating system structure. Well, in a user mode rootkit, the, the rootkit lives on application level files and modify standard system utilities. And actually, in the stealthy side, the user mode rootkit lower and easier to detect and remove. But in a kernel mode side, the rootkit lives on operating system kernel on modify or replace kernel modules and drivers. But the technique is highly stealthy and harder to detect. It. In most cases, require dumping the memory, the RAM, on an infected machine and using tools like a memprogfs, recall, cyber triage, and, or volatility to investigate further. Well, rootkits have their own different technique and mechanism to stay undetectable on your operating system. One of them is um, altering e-process and hiding there from uh, normal utilities. Because as I mentioned it, um, you can look at any kind of the process on your operating system, but for rootkit side, it's not possible. You cannot use task manager. You cannot use process hacker. You cannot use process explorer, process monitor, and so on, because the process is hidden actually. Well, the chain of hiding process from e-process is first of all gain a kernel access. Rootkits loads into the ring zero. We have a ring zero, ring one, ring two, ring three, and so on. Sorry, I think it's only three rings, but the ring zero is a the highly privileged one. So ring zero means yeah, working on a kernel land. And then find address of its own eProcess structure. Well, eProcess is a kernel structure that represents data about the running processes like a process ID, process name, modules, handles, virtual memory, and so on. Well, actually, you can see it as a database of own process. In a database, actually, you have all information: ID, name, age, phone numbers, and so on. Well, in an e-process, it have information about uh, their own processes. Okay, because in a Windows internal side, each process have their own heap, stack, loaded module, and virtual memory resources, PID, and name, so on. And then locate the forward link and backward link pointer in a list entry from the eProcess structure. And one of the main important question how this rootkit is performing the DCOM, direct kernel object manipulation technique. Well, it simply changes value of filling and billing to remain undetectable. Or in a technical terms, a change filling of previous process to next and change billing of next processes to previous. And finally, process is hidden, invisible to user mode tools, and still active in memory. And we move into the demo. Well, I have decided to use two tools, BIMprogfs and volatility. That's a query, vol.py, infected kit.row and windows.modules. Well, in this side we have rootkit.sys from the hidden path, and we have a decom.sys from the hidden path. But actually, we have something interesting called uh, Euritaka sys from the temp directory. It's quite suspicious that why a driver should be loaded from the temp directory. And from this minprog side, as you can see from the object root drivers, we have the uartica.sys, our suspicious driver. Well, that's our table of indicator. We have a rootkit.sys from the hidden path, and we have a decom.sys from the hidden path. Also, we have a udatakas.sys from the temp directory. It's quite suspicious, and that's their own addresses actually. Well, you can actually um, enumerating the drivers from the registry key. Actually, the registry is a database of entire Windows operating system information. Well, actually, from this query, windows.registry.print and control set 001 service, we have something interesting called uartica.sys. And from the minprog fs side, we have also the same one. You can look it on the right side. Well, again, the image path of uartica.sys, again, is a local temp uartica.sys from the registry print key. Well, I have decided to dump the uartica.sys through windows.modules and / name, sorry, hyphen name, uartica.sys hyphen dump. When decide to upload onto the virus total, you can see the Trojan rootkit Windows, Win32 dot blah blah blah. So actually, it's a clear that a rootkit. You can use this query to dump the suspicious driver name through a volatility. But if you use a minprog fs, it's a quite easier. You can just drag and drop. Well, I have decided to use a vol shell. Okay, it's a shell mode on volatility framework for memory forensic purpose. I have decided to search for uartica.sys in entire operating systems, and from using modules like a mod scan and driver scan, also importing the module section as appear from the side. And uartica.sys is available over there. Well, from the event log, we can see something that interesting. So service name uartica.sys and file name from the temp directory, and service type kernel mode driver, so it's not a user line, and actually daemon star. Well, that's quite suspicious actually. And you can uh, look at on the right side from the params, device hard disk volume 2 users has been updated and local temp uartica.sys. That's quite interesting. So actually, the event viewer, it's a software, it's a utility entire from the Windows operating system. You can look at for entire activity that you are done and you are doing for your operating systems, like a creating file, open the process, or sometimes when you install the software, it show that software is created. I'm sorry. In a second demo, there are something interesting. A tx platform.exe from system32 tx platform. That's quite suspicious because there are no software names like this actually in a system32 path. Well, it load the drivers called QA assist, and actually QA assist from the driver modules is available through a volatility. When upload into the virus total, actually it's a rootkit. And that's all about our presentation. I hope you are learning something new.